Okay. And live we go. All right. Let's see. Who of you, just to see the temperature in the room, who of you have used adaptive components in the past? You can just raise the hand, the digital hand. So it looks like only Lindsay, Isabella as well. I recently read that I recently find that on Zoom, if you raise your hand, it should detect gestures or maybe not. Recognize hand. It's supposed to recognize hand gesture, but it's not doing it for me. So it's not working. Okay, so it's adaptive components is a topic that is not taught quite often in curriculums, but it's something you need to be aware in case you find opportunities to use it in exploratory design. I find that the most applications of adaptive components is when we are building parametric design, usually driven via computational design methods. And but let's see what is adaptive component. I'm gonna start by opening a file. You don't have to open it with me, but I am going to open an example that I got here. Give me a second, this is frozen for some reason. Okay. Let me open this. All right, so this is a representation of a panel with an opening. When we build typical families, and we were doing this in curtain with the curtain walls, they follow certain rules of shape. Curtain walls, for example, can only be nested on in a rectangular host. See, but when you need to build panels that follow an organic pattern or asymmetrical non-flat structures and subdivided, sometimes it's useful to use a type of family that is flexible in its shape. And so think of these, an adaptive component is a family that is made by adaptive points. And an adaptive point, it's a defining structure within a family that anchors the family in a host. So this family is made of 4 adaptive components, but the ultimate shape of these, it's based on the host project. And so this adaptive point can be shaped of any size and can be placed in any X, Y, and Z direction. The panel size can be used in panels of different geometry, and it automatically resizes itself. Adaptive points, it's a point that hosts other geometry. An adaptive point is made of, I'm going to create a point here for illustration purposes. This is a point in space that can only be built inside the adaptive point family template. But this point can be converted into an adaptive point in which it becomes a vertice that defines the boundary of a family. And so This adaptive point has 6 different planes. Each of these planes can be used as a work plane that hosts geometry. And you can utilize reference planes that snap to the point and lock to the point. Or you can create profiles that are hosted by the work planes of this point, and use those profiles to create extrusions or to create sweeps. Because the profile is hosted by the point, and then the solid is associated with that profile, wherever the point moves, the profile moves with it. And wherever the profile moves, the solid moves with it as well. And so the base, or the base of these smart geometry, it's all our ability to utilize the working planes of the points as anchor points for profiles and points and lines. And so the adaptive points comes in a sequence, noting that there is 1, 2, 3, 4. When these families brought inside a project, Revit doesn't know where to place this. How are the shape of this? It's actually derived by. It's something that we need to define inside a family, inside a project. And so the shape of this plane can take multiple different forms, but we're just utilizing one family, and this single family can have unique configurations and still be able to schedule shape, boundary, materials, etc. So to put this in action, I'm going to delete this point. Notice how there's a number associated with these points, and which indicate the order in which they're going to snap in a host geometry. And we can build something with these adaptive points. So let's do this. We can do this together, I think. But we need to access this file as well. So I'm going to put a link to this file. So this is the 4 module. I'm going to share this Google Drive, copy link, and paste it here. All right, I just pasted in the chat panel this file. Go ahead and download it, place it in a place that you can retrieve easily. I'm going to close this file. And we are going to model an organic a surface that will be subdivided in X and Y. The grid is going to define a set of 4 points, and then we're going to repeat that. We're going to load the adaptive components, and we're going to adapt it to every grid intersection of this surface domain. Okay, we're not going to build it from scratch because it's going to take us probably a couple of hours to do from scratch. I'm just going to show you the logic behind it, and then we will jump into generative design. Okay, so let's start a new family, not model, a new family. So a new family, and open in the English Imperial template, open the generic model adaptive. So the adaptive points template, it's slightly different than the other ones. It has a different way of creating solids. The solid editors inside this is based on, I mean, you can create the same type of shapes, but you can actually build them in 3D. Actually, this is the only template that you can actually display levels and working planes. You can actually select them. And you can switch, you can select working planes very easily. Let's do an example where we assign different work planes. So you go to the no, in the Create tab, you see where it says Set Work Plane. Set Work Plane. Pick the center right. And if you click the Show button on the work plane, that is like, what is my active work plane? So setting a work plane, I think we've done it several times. Allows to switch working planes in the vertical, in the horizontal. Again, set work plane. And usually in the Revit editor, you're presented with drop-down lists of work planes. In the adaptive component template, you have to pick a work plane on the space in order to make that plane your active work plane. And so on the floor plan, I'm going to switch to the top view. And I'm going to create two reference planes, one below the existing reference plane, another one above. So I'm looking at the floor plan. You just switch to the top of this view, of the 3D view, and create a plane. I'm going to create a plane in the placement plane, pick the reference level. Again, and we'll create a reference plane here and another one here. Again, you hit the plane tool. And then when it says placement plane, switch to reference level. That's the ground reference plane. Work planes need a work plane in order to be placed. It's ironic, but a work plane needs a work plane. So I'm creating a plane that needs as a reference, the reference level as a work plane. And then I created a one here and another one there. I'm going to return to the home view. The home view, start this here. This is working now. Okay, here in the view, I'm going to switch again to the one of the corners. All right, so I have three parallel reference planes on the X direction. So I'm going to use these three reference planes to create some kind of a three-dimensional pavilion. And the pavilion is going to be built based on the extrusion of three reference lines. So, or model lines actually. Okay, you have three reference planes here. I'm going to use the model tool here to create a SP line. The SP line, it's this tool that has like an S shape with little dots. This is the SP line. This option is not available in the project or in the regular family. This is only available in the adaptive component templates and in the massing environment. So you go to the model, SP line, and then hit the set work plane, and pick the work plane that is at the very closer to the front view. That's my active work plane. In order to make it visible, make sure you have this show button enabled. Just enable the visibility of the work plane. And I'm going to make a 3-point curve. So starting from the ground or close to the ground, and I'm just eyeballing here. There's ways to make this very precise. I'm just eyeballing here. So first point, second point, and third point, then escape. Again, this is hosted by this vertical plane. If I want to repeat this again, you go to plane, set work plane, and you select the work plane. And then you go to model line, pick the SP line button, and create a 3-point arc. 1, 2, 3. Just eyeball it. I mean, one of the nice things about this geometry is that these points stay as vertices that you can push and pull. You can always go back, grab these points. And notice that every time you grab a point, the work plane changes. It changes to the normal plane, or the plane that is perpendicular to the line at that point. All right, so that was my first arc. I'm going to do another one. I'm going to use the center one as the second plane. So you go again and set work plane, pick the parallel work plane, and then I'm going to create a 3-point arc, but this is going to be slightly bigger than the other one. So I switched to the front view just to see the proportion or the offset, and then hit the SP line 3 points, and this is like from here to here to there. It's a little larger on that end. You know, I can always lower or change the shape afterwards just by grabbing those control points and adjusting them as needed. And I'm going to do the last one. Again, I need to host this model line in the third parallel work plane. So you go into set work plane, pick the third work plane, parallel work plane. And again, I'm going to switch to the front view so that it's easier to see what I'm doing. And then I'm going to create an SP line, 3 points. And I'm going to do it like in the middle of these two guys. So it will be this one, 1, 2, and 3. Escape at the end. You can do more points if you want. I choose to do 3 points because I want to do like this tunnel. But you can experiment as well. If you want to do it something different that I'm doing, feel free to do so. You can do 3 points or 2 or 4 points or 5 points. Okay, so this is the let's say these are the profiles that are going to define a surface. And so I'm going to create a surface by ruling an extrusion organically between these 3 lines. And one of the things of doing solids in the generic model is that you select the profiles, and then Revit automatically is going to detect your intent. For example, I want to create this a surface by extrapolating these three structural profiles. You select the first one, hit Control key for the second one, hit Control key for the third one. I have selected 3 objects that you can see in the filter, and then I just create a form. This form, I'm going to change this to shaded. You just take the shape, and actually it's nicely rendered. It renders the light pretty nicely. It's a shape that it's like an egg, and it is made of these three lines, by extruding these 3 lines. This shape, when you select it, I mean, you have to select element by face. I am enabling selecting by face. You can always X-ray it. X-ray means display the underlying geometry of this surface. And when you enable X-ray, it discloses the organic shapes, where you can go back and pick those any of these points, and using these directional arrows, you can come back and change the shape of the surface. I'm just going to make a couple of adjustments so that it looks kind of cool. Maybe I do some eccentricity here. And notice that the point displays along the work plane the model line is hosted. So I can only move it in the I can move it in the XY direction of the working point. And I can also move it perpendicular to that as well. So, but if you do that, you're moving it away from the work plane. Okay, so go back, I mean, enable the select by face. That's the 4th icon from the lower right. It's select by face. That means that you touch in the middle of a surface and it select that surface. I'm going to disable the X-ray here. And now I am going to load that panel, the panel that I brought in. So go and insert load family. I share with you this family called 4-point module. It's in Google Drive as well, and I share the path in the chat panel. So it's this 4-point module. I'm going to load that. I think it's going to ask you to upgrade, and that's fine. When an adaptive component is loaded into another one, it will be available to you under the family branch under generic models. And notice that there's a 4-point module adaptive point. So let me show you how the adaptive component works. If you select the adaptive components and drag it into the project, Revit's going to start asking for a snapping point for each of the adaptive vertices. This family has 4 vertices or 4 points. So Revit is going to ask me for 4 hosting points. So you select the adaptive point, drag it, and then it says, what's the first point? Is this one. And I'm just clicking in open space. Then And notice there are two ways of doing this. You can put it on a face, or you can put it in a work plane. I'm going to say work plane, and then it's asking for the second point, and then the third point, the fourth point, and when he finished the fourth point, then he places the component. I wasn't very, because I don't have any geometry to snap to, then the family just take the shape of whatever point I am selecting on this work plane. And so right now, because I told him to place it in the work plane, is hosted by these work plane here. But placing it just in the air without any host is not really a good use of this adaptive component. It's best to provide a supporting structure by this surface. So I'm going to delete this adaptive components, and I'm going to subdivide this surface in a domain in UMV. So you know that a surface can be subdivided, can have two directions, U and V. These directions are perpendicular to each other. And Revit can subdivide a surface using the divide surface tool. So what you do is you select the surface, make sure you have the enable surface in the lower right corner, and click divide surface. And the default properties of this divide surface, it's a grid that is 12 by 12. I'm going to make the process run faster, I'm going to make it 9 by 9. So in the divided surface instance properties, these are the rules that control the X and Y subdivision. The rules are fixed number or fixed distance. If you do fixed distance, then there's going to be a residual. You need to decide whether the residual is at the start, at the beginning, or the end, or of center. Or you can do maximum spacing and define the spacing value. Or you can do minimum spacing and define the value. I'm just using fixed numbers so I have even. The distribution of the grid is driven by an integer. And so it has a fixed number of 9, justification center, it doesn't matter. Actually, you can ask the grid to start from the beginning or to the end, but because it's a fixed number, the results are always going to be the same. This is the rules on the U direction. These are the rules for the V direction. And so, okay, you guys good here with me? And anybody needs me to repeat anything before I go too far?
Just quick question. If you needed to control how you divide the grid, is that even possible?
Divide the grid, you can do it using these rules. So this rule, oh, you mean individually? Like
yes.
No,
you can't
right?
tab and select a grid, individual grid.
No, it's not like a
okay.
Like the curtain walls, you know.
Yeah.
No, you cannot.
Okay.
A divided surface, it's just evenly distributed or driven by a distance, and then you have these partial modules, but you cannot like individually control the sizing of each of them.
Okay, thanks.
Any other question? Anybody want me to repeat anything? All right, so now that I have this subdivided surface, I can make the surface display the UV intersections. So the way to do this is where it says surface representation, you see this little arrow pointing down. Click on that arrow, And then this is how is the surface represented. You can make it display the original surface. I don't want to do that. If you do that, then it's going to add a material. But in the case you want to like represent this as glass, you can do that as well. But you want to display the nodes, and the nodes are all the UV line intersections. Okay, and then you hit OK here. You can always go back and adjust both the surface, or you can go back here and select the surface and make it actually now I believe there are two elements on top of each other. Yeah, you see there are two elements here. One element is the divided surface, which is the rule, the UV subdivision, and the generic model, which is the surface itself. So if I select the surface itself, you can always access the control points in the original SP lines, change it, and the subdivided surface will follow. Okay, but I want to, you can always hit the surface, hit tab. This is generic model. Here's where you access the X-ray, and then you can go back and display the thing. All right, so to select again the divided surface, tab, you can do a crossing selection. Wait, I need to deselect everything. And where did it go? I need to disable X-ray. Okay, so there are two filter elements here. The selection of these elements, it's just a little tricky. You cross-select both elements. You have two elements. Then you select the divided surface, which give me access again to the surface visibility. I disable the visibility of the infill panel, and then I just stick with the like say the grids. Okay, everybody with me here? Anybody have a question?
Yes, I do have a question.
Yeah.
Can we add like CAD drawings as in regular families in work planes to help us with, SP lines or whatever drawing we are doing in these work planes?
So you're asking if when we are doing these the profiles, can we add other type of families? Is that what you're saying?
Yes. So in regular families in Revit, in mullions, for example, we can add detail items.
Okay, I got it.
Yeah. So this is what I'm asking. But if we can add different kind of families in different in these work planes that we are creating.
When you use this adaptive component template, it's a unique animal within the Revit environment. And so you can nest an adaptive component inside another adaptive component, and that component can be nested in another component. For example, I can create an adaptive component that represents a profile, a circle, for example. I can bring that adaptive component inside this and use that adaptive component as a profile, but it's not going to be listed as as a family of the profile category, it's an adaptive component with a circle that is acting as a profile. So you can nest adaptive components inside another adaptive component inside another component, and they play different roles, similar to the ones you find in the family editor, but you cannot combine. Like I cannot bring here and try to make part of this geometry, let's say a column or a piece of furniture or a panel. It's not compatible. I'll consider this like a little sub program inside Revit, but the results of these operation of this model, for example, I can bring it into a Revit project, and I can draw sections, elevations, and it becomes part of the project with the line weights associated with the genetic model category. So hopefully that answered the question, Lydia.
And I do have another question. I'm sorry.
Yeah, that's what.
Can we change? We can only change the SP lines in the family and not in the project, right?
Correct.
Okay, that's good.
So the vertices that define the structure of this surface can only be changed in the family editor. Once this is loaded into the project, you won't have access to those. Those will be invisible. Yeah.
Cesar, where is the X-ray command? I always miss it.
You have to select the surface. And so if you do a crossing selection, open the filter and select the generic model surface, then you have the X-ray here.
Oh, it is tricky.
Yeah.
I want the which one do I need? I need the generic model.
The generic model. The generic model is the surface, and then the divided surface it's a parallel entity with the generic model.
Yeah, that one always gets me.
Yeah.
Okay.
All right, so I go back, use the filter, see the crossing selection. Oh, I have to escape. Right now I select these two. Where it goes. I need to disable the X-ray first. Yeah, and now I get access to the grid. Okay, so all of you have the node displays. When it becomes very interesting now is that you can snap an adaptive component to one of these vertices, and you can do it one at a time and start populating all of them. But Revit has the ability to array adaptive component as a pattern across the surface. And that's exactly what we're going to do now. So I have in the families branch, the 4-point module. So just drag it and drop it. And Revit is asking, where do I put this point? So you're going to have to snap these points using a clockwise direction in one of the grids subdivisions. And so my first point is going to snap when it says placement plane, you place on face here. Why doesn't it start here? Place on face. Oh, here. Make sure that when you drag and drop it, make sure you enable place on face, because otherwise it's gonna try to put it in the work plane, and that's not where I want this to go. I want it to go on the surface, and I want it to snap in the node. So you're gonna see this big circle, red circle, as a visual indication that that is the node that you're gonna snap to. That's point number one, and go clockwise. Point number one, then go to the next one, point number two, and make sure that this red dot highlights. That's the only visual reference that is snapping to the appropriate node. Then snap to the other point. That's point number 3. And then the last point, number 4. And then hit escape. So this panel is anchored to the surface, and this surface can change in shape. I can go back, I can select the 3D panel and make changes to it, and the panel react to changes in the surface because it's the host is actually what's hosting it. And everybody with me here?
Somehow it's not, I'm not getting you said clockwise rotation.
Yeah, and make sure that when you place it, that you enable place on face, not on work plane.
Yeah, I'm doing that. It's doesn't want to create the final snap doesn't want to create the object. Clockwise rotation, right?
Yeah.
Does it matter which one number 1 is?
It doesn't.
So,
And you have the nodes enabled, right? Like you can see those nodes.
yeah.
Um,
So I takes 3 of them fine, and when I do the last one, I get a error message. Can't make type 4-point module.
Maybe it's very small and the geometry fails. Sometimes when the distortion on the
curves
and the curves is too drastic, then there's a void nested inside this panel that I think is limited by some curvatory. So if the deformation is too big, it might not be able to form itself.
How about if I increase the grid size?
Yes. Correct.
So we'll do 11.
So while he's doing that, so this is sort of thinking ahead, like if this is a roof, let's say we're putting on something. So you're kind of laying out the family as an independent model.
This is a family, yes, a family hosted to another family, yes.
So you're going to insert this family like a prefabricated roof onto your Revit project.
Yes.
Yes.
Okay.
Good question. Yeah. So this type of modeling can only happen within the generic model environment. Like the grid subdivision, the node only happens in this environment. And then these roof, you can bring here like a profile that helps you build this precisely using the project as a reference.
Right.
Or you can bring model. I think model lines can be pasted between the projects, but you cannot bring the project here. Like there's no way to link a Revit file here. So the base geometry to generate something like that needs to be like a CAD drawing or a set of lines that you can use as a boundary, as a reference boundary to make it fit within the project. That makes sense? Yeah.
Yes, thank you.
Are there types? Sorry, are there types in these adaptive components?
Yes. So you see, this is the categories generic models. This is the family name, the family, and this is the type. So the type is 4-point module. You can always duplicate it and then access if I define custom parameters in the family environment. I can access those type parameters here. You see how I have different radius and different dimensional constraint here. So like, I think these dimensional constraints are define how big the circle is relative to the edge. But I can have multiple types, like I can have 4-point module instead of 6. I can make it a foot with a radius of 4 inches. So the shape of that circle is going to be different from the other type. So you can have multiple types inside the same family. I think that was your question.
Yes.
All right, and here's where the magic comes. Once you have one component placed, then you select that component, and Revit has this thing called a repetitive component. So under the Modify tab, it's this 4 little button with a little P. And when I click here, this panel is going to be distributed across all the surface. It's going to take a minute or two to get it all processed because there's a lot of graphic representation that needs to happen and a lot of refresh. But what Revit is doing in the background, it's calculating the shape of each of this panel, snapping it to every subdivision, resizing the adaptive component as needed, and voila, here it is. So I did very quickly a panelized surface with an adaptive component. Now, this reacts to changes in the subdivision. So I can go back. Now I have several elements under here. It's tricky to select them. You can tab select them, but you can always do a crossing selection, filter, and pick the divided surface only. And say, I want to increment the size of this. And instead of 9 by 9, let's say I want to subdivide the V grid in 12. And that's it. I apply it, it subdivides the grid, it regenerates the pattern as needed. Again, it's going to take time because it's recalculating the grid, recalculating the shape of each of the panels, etc.
Can you apply 2 types in one form?
You know, the repetitive command only takes into consideration one of them, but you can tab select. You can tab select and swap it, I believe. So if you tab select this, here I selected one, a repetitive component. Form. Yeah, I picked that one, and I'm going to swap it with a 4-point, which has a different type property. So now this is unique from this one. I don't see the changes. It's not very clear what the changes is, but this is a different module. So give me here, I can say no component and make it empty, like this could be an entry door or something like that. So you can individually start swapping the panels with other ones, but that has to be manually.
When it's grinding away, is there anything that tells you it's actually working and that you just haven't frozen up?
There's a progress bar, but you know, I was looking at it and it was like 0%, and it went from 0% to 100%. So I don't know. How big is your grid?
Where's the progress bar?
I would see in the lower left side when
Uh-huh.
when the pattern was
Okay.
calculated. I don't know if you see it.
So like that top panel that couldn't display the cutout, the void, can you diagnose what's wrong with that panel?
Um,
Yeah, it's related to the size of the grid. If the grid gets too small, the circle in that family is somehow not flexing.
yeah. I mean, this is, if you open this family, let me show you how it works. So there is a reference line with circles that are extruded between two profiles hosted by the vertical planes. That creates this frame. And then inside here, it's another nested family. This is a 3 bearish curve that it's nested inside this other family. This is another family.
I think that's where it's breaking, something about that opening curve.
And I'm gonna make this a wireframe. Yeah, so you see these are reference planes. Then there's another set of reference planes snapped to the midpoint of this reference plane, the start and end point of these reference planes. It's a relative position based on percentage. For example, you can say, place this point 25% away from this other point. So whatever the shape of this is always 25% from that point. And then the midpoint of all these reference planes help me place a 3-point component, which is this bearish curve, which is, there are 4 P lines snapped to the midpoints of each of these segments, which generates a closed loop. And then that closed loop is created as a void. That's the void here. And then the void makes the hole. And so if these 4 points, if the diagonal direction of them sometimes is too extreme, then the creation of the void is not big enough to cut the hole.
Right,
So,
right.
yeah, there must be a
Void
limitation.
was thicker, perhaps that would do it.
Yeah, like you can select the void and make the extrusion bigger. Let's see if I can select it here using filters. Here's a void, generic void. That's the void, and right now it's always driven by parameters. Is this 3T, which is 3 times the thickness. So in the formula, 3T, 3 times the thickness, you can make it 4 times or 6 times the thickness. And so now if I selected the void, you see how now it's thicker, it's bigger. So I can maybe load this into the project and replace it.
There's the bar.
Here's a bar, you see?
It would be cool if, might be too complicated, that, you know, if you ran this to a thermal model, if it has a certain percentage of solar, that the void would shut down, would not
Yeah.
appear.
There's, you can do that via Dynamo, and there's several tutorials of that in YouTube. But it's exactly that thing. I mean, Dynamo has a solar radiation. Dynamo is like Grasshopper. It's a computational design tool, and has a solar radiation panel that detect the vectors of all the different sun positions, and then it uses the direction of those sun rays to calculate the angle between the normal to the surface and the angle of declination. And so the lower the angle of declination, the bigger it is. And if it's like perpendicular, it closes. And so that's pretty cool.
Yeah, it's got a really good YouTube tutorial on it. It's kind of long, but it's really cool.
Yeah.
Didn't work.
It didn't work. So there's something else. And you saw the warning when I loaded, it gave me the warning that something wasn't working. Let me tab select this.
I found this panel sensitive to scale when it wasn't working for me, and I made them bigger, fewer number divisions, and it solved the problem. But I don't know if these two things are related. My hunch is that they are, but I don't know.
Yeah. Yeah, I don't know. I mean, I think I could, it wouldn't, I know I'd make a change to the panel via, let's see, I return this to this. It doesn't make any difference. I'll have to diagnose more.
Can you that panel and recreate it? Maybe that one panel is corrupted somehow.
I can say no component, and then but I doubt it, because what I'm doing manually is exactly what the repeated pattern does.
Yeah.
So I think I'm gonna have the same. Is it plain thing? Oh, I snapped the wrong one.
Oops.
The last one. Or I'll just leave it open. Yeah, I'll diagnose what that later. I just want to give you I wanted to give you a little taste of adaptive components. You can build one very easily. I'm going to do one very easily just using a 4-point and one of those. Let me give you quickly another example here. I'm going to open the 2-point panel that I shared with you guys in Google Drive. Revit. Where is it? There's a project called Adaptive 2-point pipe. I'm going to build it here. So I want to show you how this works. These are 2 points, adaptive points, with a reference line that snapped from point to point. So wherever the point moves, the reference line moves. The end of that reference line has a work plane that hosts this radius circle. And then the two circles are extruded and connected. But not only that, the radius of this circle is driven by a formula where the length play a rule. Because I mean, this pipe can be nested anywhere. You don't know where this is going to go. And so instead of creating different types with different radius information, there's a formula that says here that if the length is of a, it has a variation. It says use a larger calculation. A larger calculation means that if the length, the reporting length, is it's if this checkbox is enabled, subdivide the length by 24. And if it's clear, if it's not, subdivide it by 48. So the radius of the circle can be two variables depending on the length of these tubular component, and which is very nice. So right now this is clear, and if this is clear, the radius is divided by 48. So these adaptive points, I'm going to select the point and move it around, and the radius becomes smaller or thinner depending on the size of the component. Let me try it again. So if I go back to this type properties and I enable this checkbox, which is used for larger calculation, that means it's going to divide it by 24. And you see this the radius became bigger. And so as I change the length of this element, then you see the radius is becoming smaller and thinner. So it's reacting to changes in the length. And so this is a smart way to create geometry based on proportions. So it's really the proportion of the host that's driving the size of the radius. So if you host this in a grid that is very small, then the tube is going to react, the size of the tube is going to react and be smaller. If you host it as a panel in a really big structure, then you can also enable that checkbox and make those tubular sections larger. So very quickly, I can create a new family, and this family is going to be an adaptive component, generic model adaptive. I'm going to create 4 points there. Point number 1, point number 2, point number 3, point number 4. These are from the point menu. And then these points need to be converted into adaptive. You select the 4 points in the screen and make them adaptive. The number is based in the order in which they were created. So point number 1, 2, 3, 4, it's in a clockwise direction. You can change them actually. If you select this point, you can scroll down and change the sequence number if you didn't create them correctly. So once the points are converted in adaptive points, I can bring the tubular point. So I'm going to load the tubular points into the other family I created, family 2. And then I'm going to create an X. So this goes here, let's go there. And then the other one goes from point 2 to point 4. And then in order for these to appear clean. I think. No, I don't think I can join geometry inside there. There's no join geometry in Revit here, but this is what this looked like. Very simple. Those two tubular components by 4 points. I'm going to save this as a family, and then I'm going to call this the X race adaptive. I'm putting it in the Google Drive so you can access it if you want. X race adaptive. And then this family I loaded into my first family where I had my, not this guy, this guy, which is called family 1. So I'm going to load this into family 1. And then again, snap to the nodes, make sure that the node is activated as a red dot.
So that's a lot of confusion right there. How do you isolate just nodes only? You can't, huh?
Isolate the nodes so that only the nodes display.
Or only nodes are allowed to snap. Because right now you're snapping into a lot of the components, endpoints and stuff.
Yeah, first I will switch to wireframe, and the other one you can force the snapping by typing on the fly SN. So if you type SN on the fly, that is snap node.
Not okay. Gotcha. Thanks.
Yeah. And so instead of intersection endpoint, you SN is snap node. So here when I go to this 4 point, the adaptive race, and unless I do something, SN snap node. Oh, it's not doing it. But you know, the node representation, it's a circle with an X. And so when I snap and you see that circle with an X, that is node. It's supposed as intersect. Endpoint is a rectangle. Like midpoint is a triangle. Like those are visual ways of seeing what you're snapping to. But when you see a circle with an X, that is a node. And there's only one node in that location, which is that intersection. And by default, when you're placing, when you put your mouse over a node, it automatically uses that as a snapping reference. Here's the component. Return it to shaded. I'm gonna repeat it across, so it's gonna remove the other adaptive components, and it's gonna be replaced by this X that I just created. And this was just a quick example of creating a new adaptive component made of 2 adaptive components. You started with the tubular points, the tubular representation that is nested into another component, and then this could be part of. Oh, it didn't replace it. Oh, that's a new for me. So you can have multiple adaptive components living on top of each other. Nice. Cool. So different things can be overlay on top of each other. Like I just demonstrated here. All right. So I think this challenges the notion that Revit can only do orthogonal stuff. You know, a lot of people think, oh no, you cannot do crazy stuff in Revit. You can actually do a lot of design exploration if you knew how to use the tool correctly. And so this is, and part of the problem is that a lot of the curriculums in Revit don't teach this or don't expose the users on how to properly activate this type of exploration. And so a lot of this is not utilized in design solutions because it's simply not something that a lot of users know how to do. And so and then in addition to that, there's another side of this, like Dynamo. Dynamo is a computational design tool for Revit. I have taught Dynamo a lot at universities, and I have a course at Get Globally Training. That's another thing, if you guys are interested, like you just have a class on Dynamo, which I never done for this course. I could put like a 8-week class, just focus on how to learn all the basics of nodes and how to start using advanced features in Revit API. So what Dynamo does, it's access the Revit API that otherwise is not exposed or not accessible to you, and then use visual scripting to build things that Revit is not built to do. And so it accesses the Revit API and create customized scripts to do site exploration or sustainable analysis or design options. All right, so once you finish this family, you can load it into a project and just place it wherever it needs to be. The placement location of this family is this reference plane. So make sure that if this is going to be used in the context of a project, the reference level is what defines the placement location of the component. So if this is going to be a roof, that's going to be the alignment placement for the family. Here under the family category and pattern, notice that there are some choices here that make this always go vertical, in which case you can't host it to custom work planes. Or if this is disabled, then you have the ability to pick a work plane, and the placement work plane is this guy, the reference level. Okay, I only have like 15 or more minutes left, and I want to give an introduction to generative design. So feel free to save this work on your end. I'm going to just use the some of the out-of-the-box capabilities of generative design. Quickly. So let's go ahead and create a new project from scratch. Save what you have created. Create a new project from scratch. And under the Manage tab, out of the box, you're going to see this tool called Generative Design. So what's generative design? Generative design is an optimization tool that allows the creation of this and exploration of design solutions based on a custom script that allow a user to define what kind of inputs are needed to do the study and what kind of outputs are needed, are expected to produce. So think of it as an engine that processes a custom script where you can measure the amount of value you give to each of the variables that define design problem. So it's better to illustrate it by using one of the out-of-the-box solutions. So open the create study. And when you do that, you're going to see a generative design panel on a side. It went to my other screen. There we go. I think my Revit went to no man's land. Let me close it. Oh, there you go. Okay. So each of these studies is first built using a Dynamo script. So to create a custom study, yes, you need to be a little knowledgeable on how Dynamo works. For example, this is a 3-box massing. This generates a massing model that varying the heights and the location of these 3 boxes, and it calculates facade area and floor area. If you click the question mark, it actually is a tutorial. It's a tutorial on how to get to the files. And so if it does require you to open a Revit file that ships with Revit, that Revit, I mean, it needs inputs that are picked from a Revit file. And those files are nested in this folder. It's program data, Autodesk, Revit, samples, release 23. And I can share this path with you guys here. Let me a second. I'm gonna copy this. And in the chat panel, I pasted the just copy that and paste it into your window explorer, and go to the English US, and these are all the different these are the scripts. There's one called 3-box massing dependencies, packages, generative design, bin, English US. Wait, so these are all the DLLs. No, they didn't pack the they didn't send the Revit file in the out of the box. I would expect it to be sitting right here, but it's not. But it says here that if it's not available there, open link, copy link address. I'm going to share another link with you guys. Under the chat panel, here's another link to download all those files. 3-box massing study. There's a zip file to be downloaded immediately. It's this Revit generative design 3-box. Unzip it, extract all. No, it's not giving me any Revit model either. Okay, so that's not gonna work. That's a bummer. I have to report that. But let's do another of these studies. This is a step grid object placement inside a room. For this was created during COVID, and for a while, firms were attempting to, like, you know, when you were doing distribution of desks, you wanted to make sure optimize the distribution of desk based on separation distance. And so that's exactly what this does. And so we can build that very quickly here. Let's create a room of any shape. So I'm gonna create just a typical wall, and it goes from level 1 to level 2. And I'm on level 1. I don't know why it's not letting me do this. Wall height, yes. Rectangle, maybe. It doesn't want to do that. Let me restart Revit. Sorry, I don't know what's wrong with my Revit. New model of the architectural template. And then just create a simple wall. Good Lord. Oh. Start it again. So hopefully you didn't have that problem. I restarted Revit. Then I'm going to start a new project. And then just build a space, a big open space with walls. Wall. Now it works. So I don't know, I'm going to do like an L shape type of space. And then create a fillet. Trim to corner. And then right in the center, I'm going to place a room, architectural room. So the goal of the study is, I also need to like put a piece of furniture. I'm going to place the desk, the out-of-the-box desk. So if you go to furniture, furniture here, I'm going to add the 60 by 30. I'm going to put it outside here. So what does this goal of the study is? The goal of the study is place as many desks in this space separated by a 6-foot distance, for example, or provide me the optimum distance, the optimal layout of desks in this room where I can maximize the count of desks at a certain distance. And so that is the problem statement. And so generative design as an out-of-the-box study that allow you to do that. I'm not going to go into the details on how the script was put together because we need to know Dynamo a little bit. but in a nutshell, a Dynamo script, it's built with genetically designed nodes, save it in a location with all the dependencies. The dependencies are custom packages that are associated with the script, and place it in a dedicated folder that genetically designed can read and load that information, which make it visible as an accessible study. So this stepped grid project, I'm going to open it, and this is the input of the study. So there are different type of optimization methods. You can randomize, you can space evenly. This is related to how Revit treats the solution space. When you have a multivariable problem where there are multiple inputs, you're gonna have you cannot just be presented with the full population of solutions. You have to either tell the script in all the space of possible solutions. You can tell them to just randomize the selection of some solutions, or survey evenly solutions across all the different solution spaces, or optimize it. When you optimize it, it actually goes to a series of optimization exercises using generations, or you can create solutions similar to the one that you have. Just to make it faster for us, I'm going to randomize it. Randomize is not going to generate all the solutions. And then these are the type of inputs. This is the distance between the objects from 1 to 3 meters. Because it's meters because the script was built for meters. The distance in Y is from 1 to 3 meters. Minimum distance between the object and the wall. And then you select the family. So I'm going to select here this desk, and then select the room. You select this room here. This is the number of solutions that will be processed. And seed is just a random number to generate or to spark the randomized method. So it says if there was any issue, it will tell you here, and then you just click generate. This is not computed by your machine resources. What this is actually doing is pull the input information of the script and send it to Amazon server, where there's the supercomputer that is actually processing all this at a super fast speed, and then asking you to wait until this supercomputer finalizes the processing. Once the results are starting getting back, they're going to be presented as an array of grid solutions. You can see in the preview in these filter panels the number of solutions that are getting processed. Yeah, so they're starting to appear, 4 out of 40. And at the end, I'm just going to have 40 sample points of all the different landscape of possible solutions. The parts that you hear, the panels that you see at the top is the Explorer. The Explorer actually displays each of the solutions. The panel that you have at the bottom, this is called the these are ways to filter the solutions based on the weight of the value weight. So everything you see here on the top are inputs and outputs. The lines that are very, very dark are inputs, and the lines that are thin are the outputs. And so the input value changes, have different ranges from minimum to a maximum. And this is based on the minimum and the maximum values defined in the project. So number of objects, it goes from 0 to maybe 80. Object area is not applicable because we have a desk that doesn't report any area. Object area is that area outside of the room. So that is the area outside of the, like this corridor around it. Object area inside of the room. This is the area, like the net area of the desks. And then you can use these vertical columns as ways to filter the results, because I mean, I have 40 results here, but if you want, I mean, you tell me, you can get 2,000 solutions here, but reviewing 2,000 solutions might not be a good idea. And so you can go back, you can use these vertical columns to filter the input values and start displaying only the results that are applicable. For example, I know that I need to maximize the number of items, but I need to be less between 40 to 60 items. And so all you do is click here from 40 to 60, and then the number of solutions now is greatly reduced. And here is the distance between the objects in X, the distance between the objects in Y. And these are meters. So you can say, I want the vertical and the horizontal distance to be around 2 meters, between 2 and 2.5. And so you, this is the only solution that meet those requirements. Out of the 40, this is the one that gives me the right count and the approximate distance that I want. So you select this solution, you can explore the inputs and the outputs. And then if you agree with these numbers, and this is a solution that is acceptable to you after exploring, after filtering it, then you can create in Revit. And what it does, it places this family in the location indicated by the solution. Notice that because I didn't give any weight to the distance to the floor, then all this, there are desks here that don't work, right? But I can always undo, go back to the results, and maybe this time around, I disable the filters, and maybe this time around, I'm going to focus on the distance in X and Y. So I want that the distance between the walls and the area of assessment or review, it's enable filters. I have to select clear the filters here, and then I'm just going to focus on adjustments on Y. Adjustment. No, this is the distance between the projects, distance between the minimum distance. Okay, minimum distance from objects to the walls. So I want the minimum distance to be larger than 1.5 meters. So this is sample solution, and you see now in these solutions all the solutions are contained within the walls, and then I can say give me the maximum solutions, the maximum count. These are the two solutions, with an offset from the walls with 60 solutions. And so you pick this one, create Revit elements, and I move this away. Then I can, this is a solution that it actually respecting the location of the object relative to the wall. So these are just some studies that you can do with generative design. It's an optimization exercise. It does, it gives you, Revit comes preloaded with some studies that you can utilize out of the box. But I think the biggest power of this is to enable you with the ability of create this type of scripts that you can solve generatively. And so to get to that point, first you have to understand how to write Dynamo scripts. And so if this interests you, you know, I'm dying to have a course like this because I'm kind of bored of doing fundamentals. So if you want like an advanced course on Dynamo and generative design, that's like 6 or 8 weeks. Happy to put that together, maybe for the summer or the fall. Just let me know, and we can do more learning if you guys want. All right, it's 7:20. Any question, guys?
Yes, I'm interested. Thank
Oh,
you.
lovely. Awesome.
Yeah.
Yes, Caesar, I bet you Paige and Turnbull would be interested too. Paige and Turnbull.
Yes, please.
Awesome. Awesome. So I think that the next step to follow up, it's maybe if one person in each organization just survey the list of people who would be interested. And if it's 3, 4, 5 people, send the names to me and to Lana. And if we hit, you know, a minimum number of 12 people, then that's a go. Maybe we can also pick people from other organizations as well, and we can call it computational design for Revit, which will be the first one to be offered. Maybe late summer or beginning of the fall. Because on the summer, I'm going to be busy with a fundamentals course, but I have nothing for the fall yet. So we can do that as the next steps. Yeah. All right, guys. Any other question before we close the session?
Thank you, Caesar, so much.
Yeah, I hope you liked the course and that you learned something.
Yes, for sure.
I love teaching and I love to share what I know. And in particular, you know, like Revit is so big and it's so complex. And when we just do certain tasks, we usually stay at a certain threshold of information on what we can do. But there's so much more you can do above that threshold that we're not often exposed. And I think it's my job to make it visible and accessible to as many users as possible. And so spread the word. Again, keep pushing, learning Revit. It's beautiful. I love it. And next time, if this class forms, it'll be awesome to teach you guys on Dynamo and generative design.
Thank you, Caesar. Super.
Thank you.
valuable.
Yeah.
Very good. We
Thank
look
you.
forward to it.
Thank you.
All right.
Yeah.
Bye.
Yeah. Thank you.
Well, have a good
Thanks.
evening and see you soon.
All right. Yeah. Yeah.
All right.
So,
Have a good one. Bye-bye.
Thanks for Paige and Turnbull too. So to
Yay,
get
that
HWA.
Trook. I don't think Trook's on the phone. Oh yeah, Trook's there. Trook, say something.
Yeah.
It was myself and Trook that organized this, but thank you.
Yeah, thanks for your time.
Awesome.
Yeah.
Trook,
Bye.
you're amazing, Trook. Thank you, thank you, thank you.
Thank you. All
Thanks,
right.
everyone.
Thank
Bye.
you.
Bye.
Have a good one and have a good evening.
You
Okay,
too.
bye. Bye, Cecil.